Hi Year 11. Today I'm going to show you how to do Lewis dot structures, or they're also known as electron dot diagrams. Okay, so these help in several different ways. They help to predict bonding, and also further to bonding, the type of bonding, they help to figure the formula for covalent compounds, and we'll also use it again later to determine the shapes of these molecules. So let's start out by just doing an electron dot structure of a singular atom. Let's start with the simplest, hydrogen. Put the symbol for the atom there, and then look on your periodic table and determine how many valence electrons it has. Hydrogen should be nice and simple. One valence electron, I'm going to put it up the top there, a nice clear dot, okay? Now if we do something more complex, like let's go across one and we go calcium. Again, the symbol for calcium. Look on your periodic table. Calcium is in group 2, so it must have 2 valence electrons. I'm going to distribute those electrons around my symbol, and I'm going to concentrate on above, below, and to each side. But calcium just has 2. Doesn't matter where you put them. 1, 2. That's an electron dot diagram for calcium. For carbon, symbol for carbon, it's got 4 valence electrons. 1, 2, 3, 4. Notice I put them, one at the top, one on each side, one down the bottom, away from each other. Using that model, electrons will repel each other, so they're the furthest away from each other. And so we've got 4 around carbon. If we take it up to more, chlorine has 7 valence electrons. How we distribute those, draw my symbol. 1, 2, 3, 4. Now I'm going to start doubling them up into pairs. 5, 6, 7. Okay? So we've got a pair, a pair, a pair, and a single left. So that's how you do electron dot structures for singular atoms. Okay, now we're going to start talking about bonding. I'm going to do an example of ionic bonding first. I'll just rub this off. Let's say we had to make the compound lithium sulfide. Okay, what I need to do is establish what symbols I'm going to be using. So lithium, and sulfide is the ion of sulfur. Okay, I'm going to put the electrons around them. Lithium, 1 valence electron. Going to do it there, nice clear dot. Sulfur has 6 valence electrons. Look at your periodic table. Distributing 1, 2, 3, 4, 5, 6. 2 pairs there. Okay. With ionic bonding, we've learned that the more electronegative the atom, it will take the electron off the other less electronegative one. So what will happen is sulfur, because it's more electronegative, it's closer to fluorine, it will take an electron off lithium. Okay? 1 electron will move across. So now what we're going to have, lithium minus 1 electron has no valence electrons, so I'm not going to do dots around it. And I've got to give it a positive symbol because we've lost the negative. And now what we have is this sulfur with its, let's put in the original electrons, and let's add in this extra electron. And I'm just going to put it here. Okay, it's now sulfide, or it's getting towards sulfide. It's now got a negative charge. Okay, let's count the electrons around each. 0 electrons around lithium. It therefore has a full outer shell below that. It's stable. Sulfur here has 1, 2, 3, 4, 5, 6, 7 electrons. It's not stable. It needs to complete its outer shell. To do that, introduce another lithium with its dot there. Okay, now what's going to happen is the sulfur, it's more electronegative again, it's going to take this second lithium's electron And let's draw it underneath. Cool. I might put the arrow in there. It's going to jump in there. So this lithium is now a lithium plus, the lithium cation. Sulfur, with its original 7, has now got this extra one from lithium. Okay, now let's check if everything's stable. Lithium is all good because it has an inner shell, that's on video now, that's complete. So that has a complete valence shell. That one's identical, it has a complete valence shell. Sulfur, oh, I haven't put the charge on there. We've gained 2 electrons, so it should be 2 minus. So now it's sulfide. Okay. Count the electrons. 1, 2, 3, 4, 5, 6, 7, 8. It needs 8 valence electrons to complete its shell, so it has the same electron configuration as argon. So that has a full valence shell. Everything's stable. So our formula for lithium sulfide, we need 2 lithiums for 1 sulfide. So it's Li lowercase 2s. And this, that's the formula. This is the electron dot diagram for lithium sulfide. Minus the ticks there that I've used to check myself. Okay. Let's move on. Let's do some covalent molecules. Okay? Using the same methods, but they're going to share electrons this time. Okay, I'm going to start off with a polar covalent. What happens when hydrogen and chlorine bond? Hydrogen and chlorine. Okay, let's do an electron dot diagram for each atom. Hydrogen has the 1 valence electron. Chlorine is one of the halogens, so it has 7. 1, 2, 3, 4, 5, 6, 7. So, with covalent bonds, the electrons will jump in and form a covalent bond in between the 2 atoms, and each bond will be 2 electrons sharing. So this electron will jump into the middle, and this electron will jump into the middle to share between the 2 atoms, and what you're going to get is hydrogen, chlorine, and we show that there's a covalent bond by drawing a single line there. And let me just put in the other electrons. So this replaces these 2 electrons. And we count it as 2 electrons. Okay? So hydrogen now has the 2 electrons in this bond. It has its s orbital full. It's nice and stable. Remember, it only needs the 2 in the 1s orbital. Chlorine here has 1, 2, 3, 4, 5, 6, 7, 8 that exist in that bond. It needs 8 valence electrons to complete its valence shell. It's all good. So the formula for hydrogen chloride is HCl. And here is the electron dot diagram for HCl. Okay, let's do another one. What's next? Let's do chlorine with chlorine. We'll see why it's a diatomic molecule. Chlorine with chlorine. Okay, do your symbols. It's a halogen, so it has 7 valence electrons. Oh, I'm not following my own rules. 1, 2, 3, 4, 5, 6, 7. Let's do another one over here. 1, 2, 3, 4, 5, 6, 7. Okay. There needs to be a covalent bond between them because they're 2 nonmetals. So let's put 1 electron from each one going into the middle and forming a covalent bond and see what we get. Chlorine, covalent bond, chlorine. This has, these didn't change, and these didn't change. formed one covalent bond between them. Let's count the electrons around them. This one, 1, 2, 3, 4, 5, 6, and the 7th and the 8th are in the bond, so that has its 8 valence electrons. And 1, 2, 3, 4, 5, 6, 7, 8, that has its 8 valence electrons. So we've got the Lewis dot diagram for chlorine gas, or Cl2, and there's our formula for it. That's why chlorine bonds with chlorine and forms Cl2. Each atom has its outer shell full. It's sharing these 2 electrons that are in this bond, in this line here. Let's do oxygen instead. We'll see something different happening. Not too different. All right. Oxygen with oxygen. We kind of already know that the formula is O2, but we don't know why. Let's discover why. Oxygen, look at your periodic table. It has 6 valence electrons. Let's distribute them. 1, 2, 3, 4, 5, 6. Let's do the other one. 1, 2, 3, 4, 5, 6. Okay. 2 non-metals, they must form a covalent bond. Let's say this one comes into the middle and this one comes into the middle to form a covalent bond. So now we've got oxygen, single bond, 1, 2, that doesn't change, they don't change. We didn't do anything with these electrons. Let's do a count. Okay. 1, 2, 3, 4, 5, 6, 7 electrons. Hasn't got its valence shell full. 1, 2, 3, 4, 5, 6, 7. Same problem. Haven't got a valence shell full. What happens now is more electrons will go in and form bonds to make sure that they get the full valence electrons. Another hint too is electrons in this model kind of stick in pairs, and you can see this has got, these are both got odd ones here. So what's going to happen is those odd ones we can model coming in to strengthen this bond between them. Okay? Oxygen, oxygen. Now we've got the original bond, and we've got a second bond. Okay? And we didn't change these or these, so let's put them in. And we didn't change these or these, so let's put them in. And now let's count our electrons. Do a bit of accounting. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 2 for each bond. 8 electrons. 2, 4, 6, 8 electrons. Oxygen has its 8 valence electrons. Instead of sharing just 2 electrons, it's sharing 4 electrons, and that's what we call a double bond. So, let me rub that out. There is our electron dot structure for oxygen, and that is why it forms a molecule of O2. Alright, show an example of a triple bond next, with nitrogen bonding with nitrogen. The most common molecule in the atmosphere. What was the good texture? Let's go black. Nitrogen and nitrogen. Alright. Okay, look on your periodic table. You see nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? Because we know they're 2 non-metals, they'll be forming covalent bond. Let's put 1 electron and 1 electron to form a single bond and see what we've got and do our count. Nitrogen, single bond nitrogen, still has that, still has that, still has that, still has that. Okay, let's do a count of our electrons for each one. 1, 2, 3, 4, 5, 6. 6 electrons, not full. 1, 2, 3, 4, 5, 6, good, the same, symmetrical. Nitrogen doesn't have a full valence shell, it's not stable. More electrons are going to jump in and form a bond. Let's say these two go in, okay? Let's redraw it now with a double bond. Okay, what didn't change? This one, or this one, and these two. Alright, look at these ones all alone there. That's very unusual. It doesn't happen. It's kind of giving you a hint that we're not quite there yet. Okay, let's count. 1, 2, 3, 4, 5, 6, 7 electrons each. 7 electrons each. We're not there. Further bonding is going to occur. Let's pull out the lone one. 1 each into the middle to form a triple bond. Let's draw it underneath. Hopefully I'm not going down too far though. Nitrogen. 3 bonds between it. Okay, and now I've got these pairs down the bottom. Let's keep them down the bottom to make it simple and you can see the continuity. Okay, let's do our counting. 1, 2, 4, 6, 8. Good. 2, 4, 6, 8. Good. Okay. So, I'm going to move these electrons around this side just to indicate in our model that electrons repel each other. They'll want to be furthest away from those bonds. So this is the electron dot diagram for nitrogen. It's a triple bond between them. And that is why it forms, so I was going to say compound, the molecule N2. N2 has a triple bond. Alright, I think I've got 1 or 2 more. Let's do something a bit different. With 3 atoms in there. Carbon dioxide. Yeah. Carbon dioxide. Blue. Carbon in the middle. Whenever you have 3 atoms, the more electropositive will be in the middle. Carbon, oxygen, and oxygen. Okay? Let's put our electron dots around them. It's not such a good texture, I'll swap over. Carbon has 4 valence electrons. 1, 2, 3, 4. Oxygen has 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, let's put a bond in between each carbon and oxygen because we know they are nonmetals and they will bond covalently. In the middle, in the middle, in the middle, in the middle. Okay, let's draw our new idea down here. 1 bond, 1 bond. Oxygen, oxygen. There's these 2 electrons still left on the carbon. They're by themselves. And they're the electrons that are left over on each oxygen. Okay, let's count our electrons. Carbon has 1, 2, 3, 4, 5, 6. We're not there, are we? 1, 2, 3, 4, 5, 6, 7. 7 electrons. We're not there. We haven't got our full valence shell. That means more electrons are going to have to come into those bonds. Let's put that one in there. This one's by itself. Let's put that one in there. Let's put this one in there. And this one in there. So we're forming double bonds between the carbons and the oxygens. Carbon, double bond oxygen. Double bond oxygen. Okay. They're gone. That one's gone. So each oxygen should have 2 pairs of electrons around it. Alright, now we're up to counting our electrons. Carbon in the middle, 2 electrons, 4, 6, 8. 8 electrons. It's happy, it's good. Oxygen, 2, 4, 6, 8. 8 electrons, it's all good. 2, 4, 6, 8. 8 electrons, all good. So that's why sometimes when carbon bonds with oxygen, it forms carbon dioxide. And carbon dioxide has 2 double bonds between the carbon and the oxygens. Alright, let's do another. What did I write down? Oh, What formula could you expect from carbon and hydrogen bonding? Okay. Carbon, 4 valence electrons. 1, 2, 3, 4. Hydrogen, 1 valence electron. 1. Okay. Both nonmetals, they're going to form a covalent bond between them. So 1 electron to form a bond. Okay, this hydrogen here, remember hydrogen just needs 2 valence electrons to have its outer shell full. It's got the 2 in the bond there, it's happy, it's good. Look at this carbon though, 1, 2, 3, 4, 5. Okay, carbon must bond with more than 1 hydrogen. It can't put these electrons into here because hydrogen doesn't have any more electrons to share, and it only needs its 2 valence to be full. Let's bring in more hydrogens. Okay, let's bring in 1 down here, and you can see that they're going to form a bond between them too. 1 share, 1 share. And so now, we have this thing happening, and we've got these 2 unbonded electrons around there. This hydrogen that we added down the bottom is happy because it's got its 2 valence electrons. But this carbon, 1, 2, 3, 4, 5, 6, it still doesn't have it. You can see what's going to happen. We have to bring in more hydrogens. And we're eventually going to end up with this molecule. A carbon with 4 hydrogens. That's a bit terrible, but... Okay. Each hydrogen has its 2 electrons in each bond. They're all stable. This carbon has 4 bonds sharing 2 electrons, so that equals 8 electrons. So it's happy, it's got its valence shell full. So this is the electron dot diagram for a molecule we call methane. Notice there's no dots left over. All the electrons are held up in bonds. All right, so that's how carbon in one way, carbon and hydrogen can bond together. Most simplest way. One more, phosphorus and fluorine. Let's do the same thing with phosphorus and fluorine. That's a terrible texter. Phosphorus, U before O, fluorine. Okay, capital P for phosphorus. It has 5 valence electrons. Good, I got that right. I just checked on the periodic table. 1, 2, 3, 4, 5. Fluorine is a halogen. It has 7 valence electrons. 2, 3, 4, 5, 6, 7. Okay? They're both non-metals. They're going to form a covalent bond. 1 electron in there from each. Let's see what we get. 1, 2, 3, 4, 5, 6. So that's the 6 that was around there. 1, 2, 3, 4. Okay, let's do some counting. Fluorine here. 1, 2, 3, 4, 5, 6, 7, 8. It's all happy and good. Okay, phosphorus. 1, 2, 3, 4, 5, 6 electrons. It's not good. It hasn't got a full valence shell. It cannot put extra electrons into this fluorine bond. Fluorine's already happy with its 8. It's already formed a single bond. It can't change it. We can bring in more fluorines. Okay? Let's bring in 1 more. Draw it over this side. 1, 2, 3, 4, 5, 6, 7. What we're going to do is form a covalent bond by 1 electron from each atom sharing. Let's see what we have left. 1, 2, those 6. That had 1 up the top and 2 down the bottom. And this fluorine, 2, 2, and 2. Okay. Let's do our counting. This fluorine, 1, 2, 3, 4, 5, 6, 7, 8. It's all good. 1, 2, 3, 4, 5, 6, 7, 8. It's all good. Phosphorus in the middle. 1, 2, 3, 4, 5, 6, 7. Okay. It's going to, you can't put this electron into these bonds. They've already got their 8 electrons. It's going to need another fluorine. Okay. I think I can move over here in the field of view. Okay. Let's copy it out. One bond to fluorine. It has its outer shell full. Hopefully you can still see. Okay, so let's pull in another fluorine. 1, 2, 3, 4, 5, 6, 7. It's going to form one bond. These 2 electrons are going to form that bond. Why did I start down there? I should have started up there. I'm going to rub it out. Just the bond, okay? So it's now going to form a bond between them. Okay, this fluorine now, that's terrible writing. 1, 2, 3, 4, 5, 6, 7, 8. It's all good. Let's put a little tick. These were good from the previous step, but let's check phosphorus. 1, 2, 3, 4, 5, 6, 7, 8. It is now good. So, the molecule that we get from phosphorus bonding with fluorine is phosphorus trifluoride. Okay, PF3. Because that's the combination where all of the atoms will have their full outer valence shell. All right, I think that's enough. Thank you. I'll do another one soon.